Hi everyone, the question is the graph of the function f of x equal to x plus 1 by 8 sine of 2 pi x where x is in this interval 0 closed to 1 closed is shown below. Define f1x equal to f of x, f of n plus 1 x equal to f of nx for n greater than equal to 1. So this is supposed to be the graph which makes sense because at x equal to half sine term would become 0 because sine pi is 0 and you get f of half as half only. Similarly at 0 and at 1 also f of 0 is 0 and f of 1 is 1, and when x is in between 0 and half 2 pi x is in between 0 and pi, and sine being positive in this first and second quadrant, you would find that fx is greater than x when x is between 0 and half. Similarly, when x is in this interval half to 1, 2 pi x is in the interval pi to 2 pi. So here in third and fourth quadrant sine is negative, so clearly f of x turns out to be less than x. Now coming to the options, what we have been asked to comment upon is option 1, 2, 3, 4 being there are infinitely many values of x in this interval 0 close to 1 close, for which limit n tending to infinity fn x is 0, half, 1 does not exist, and we have to comment upon which among these four is or are true. So let's go back to previous slide. So basically we are interested in limit n tending to infinity f n x, yeah, and just to elaborate what is given, f of n plus 1 x, I mean f n plus 1 of x is equal to f fn of x. That means f2 of x is what? It is essentially f of f1x. F3 of x is what? Let me not write it here. F3 of x is what? It is f of f2x, which is f of f1x, and f1x is fx only. Yeah. Now if you see carefully, when x is in this interval 0 to half, we have already commented and understood it nicely that here f of x is greater than x. Yeah, my bad. F of x is greater than x. At the same time, if you see carefully, when x is in this interval 0 to half, even fx is also in this interval 0 to half. Yeah. So that means if I put instead of x, fx in this above inequality, and given that fx is also in this interval 0 to half, so I can put x instead of fx and the inequality should hold still. That means what? F of x is greater than f of x. Now if you see carefully, it essentially means what? f2x is greater than f1x for all x in this interval 0 open to half open. And similarly you can say that fnx will be greater than f of n minus 1x is greater than so and so forth is greater than f2x is greater than f1x, which is essentially fx only. Yeah. For every x in this interval 0 open to half open, and mind you, still all these would be less than half and greater than 0. Yeah. So if you see carefully, in limiting case, as you put n tending to infinity, since functional value will keep on increasing and increasing, and since it can't go beyond half, so in limiting case, as n tends to infinity, fn x will tend to half. That means limit n tending to infinity fn x is half. You may say for every x in this interval 0 open to half open. Mind it, no matter what function fn x you consider, at x equal to half the functional value will be half only. Why? Because f of half is half, so f of half will be half, so and so forth. Yeah. So this is for every x in this interval, you may say 0 open to half open. Yeah. And limit n tending to infinity, or whatever you may want to say, limit n tending to infinity fn x is equal to half for x equal to half. In fact, fn x is equal to half for every x for every n. I mean to say fn half is equal to half for every n belong to natural number. Yeah, this is what exactly what we have discussed and convinced ourselves of, and I've just written it here. And now coming to this other part, x belong to half open to 1 open. So here we have already seen in the beginning that f of x is less than x for every x in this interval half open to 1 open. At the same time, even f of x is in this interval half open to 1 open. So that means instead of x I can put fx, and the inequality would hold still. Why? Because even f of x is in this interval half open to 1 open whenever x is between half open to 1 open. So I can say what? f of x is less than f of x for every x in this interval half open to 1 open. So that means what? This is essentially f2x is less than f1x for every x in this interval half open to 1 open. Similarly, you can say fnx is less than f of n minus 1 fn minus 1 x less than so and so forth, less than f2x less than f1x. Yeah, and mind it, they all are less than 1. They all are less than 1, and they all are greater than half. So as you go for a higher and higher value of n, the functional value will keep on decreasing, reducing. Yeah, and in limiting case, that means limit n tending to infinity, fnx would tend to this lower bound, which is half for every x in this interval half open to 1 open. So that means limit n tending to infinity fnx is half for infinitely many values of x. That is not so for for first option and third option. That means limit n tending to infinity fnx equal to 0, there are not infinitely many values of x. For limit n tending to infinity fnx equal to half, there are infinitely many values of x. Yeah, and even fourth is not true. So that means 2 only is correct, b is the correct answer, and this is what we have analyzed. Thanks for listening. Stay tuned.